Hello everyone. Today we are going to dive into the exciting world of smart packaging. As consumer expectations evolve, the packaging industry is stepping up its game using technology to enhance functionality, improve sustainability, and even after interactive experiences. Let's explore the key types of smart packaging and how they are transforming industries. And this is a smart packaging. The smart packaging mainly deals with the protection and preservation of the food material, wherein the employment of active packaging, also an intelligent packaging. Put together, we can call it as smart packaging. And in the active packaging, the smart packaging mainly responsible for the protection and preservation of the food, whereas in case of intelligent packaging is mainly used in order to communicate and also for the purpose of marketing. This is one such example of the smart packaging, wherein you can look into a different types of packaging material onto a secondary and tertiary packaging material, where you can see some of the communication and marketing strategies. Along with it, you can also check with the temperature conditions, and also you can look into the barcode or QR code. See, all these types of packaging comes under the smart packaging technology. There are different types of smart packaging. The smart packaging mainly works with the active packaging. Let's start with active packaging. This type of packaging doesn't just hold the product, it actively interacts with it. For example, we have oxygen scavengers, which mainly remove oxygen from the packaging, also extending the shelf life of perishable items like snacks and meat. We also have a moisture regulators, which mainly absorbs excessive humidity to keep items fresh. We have ethylene absorbers, which mainly slows down the ripening of fruits and vegetables, controlling the natural gas that causes them to age. Active packaging is all about maintaining the quality of the product inside by creating an optimal environment for storage. The next type of packaging is intelligent packaging. It also comes under smart packaging. In intelligent packaging, which goes a step further, this packaging contains sensors that monitor and communicate the product's condition in real time. For example, temperature sensitive labels which can indicate whether a food has been exposed to unsafe temperatures, helping to ensure the product is safe for consumption. Intelligent packaging can also include time temperature indicators which change color to show if a product has been exposed to fluctuating temperatures, and gas detection sensors to monitor the atmosphere inside the package. This is especially useful in industries like food, pharmaceuticals, and even vaccines, where precise conditions are critical. The next important method of smart packaging, type of smart packaging, is RFID, radio frequency identification packaging. RFID packaging is revolutionizing how we track products. RFID tags, which mainly use electromagnetic fields to track and identify products as they move through the supply chain. This technology allows companies to monitor inventory levels in real time, reducing stockouts and overstocking. Track products from manufacturing to retail, ensuring better product traceability and reducing the risk of theft or counterfeit products. But it's not just about logistics. RFID enabled packaging can also interact with consumers, triggering digital content or promotions when scanned at the point of sale. The next important type of packaging, smart packaging, is QR codes and near field communication. Moving on to QR codes and near field communication type of smart packaging. These technologies enable direct interaction between consumers and packaging. QR codes are simple to implement, and when scanned can take a customer to a website for product details, promotions, or even recipes. What is this near field communication technology? On the other hand, NFC technology allows consumer to tap the phone to the package to access information. This makes NFC an ideal solution for offering interactive experiences and engaging with customers on a deeper level. For instance, a consumer might scan a QR code to learn about the sourcing of ingredients in their food, or tap an NFC enabled cosmetic package for detailed product usage instructions. The another type of smart packaging is eco-friendly smart packaging. Eco-friendly smart packaging focuses on sustainability, a growing priority for both businesses and consumers. This type of packaging integrates smart features while using biodegradable or recyclable materials. For example, biodegradable food packaging with embedded sensors can maintain product freshness and also break down more quickly than traditional plastics. Some packaging even includes smart recycling features like NFC chips that direct consumers to local recycling centers or provide instruction on how to dispose on the packaging responsibly. Sustainability and smart technology go hand in hand, helping to reduce waste and promote environmentally conscious consumer behavior. Like I said, the smart packaging is an amalgamation with an active packaging, also an intelligent packaging. There are different types of active packaging. For example, the moisture regulators. Generally, active packaging, a type of oxygen regulators, they mainly absorbs moisture. Moisture is a very important intrinsic factor for the growth of microorganisms. So when we work with moisture absorbers, they absorb more amount of moisture that will help in the regulation of moisture and also increases the shelf life of the product. The next smart packaging in active packaging is ethylene removal systems. We have a lot of ethylene adsorbents and scavengers. It's called as the ethylene absorbers. Ethylene is another important chemical responsible for the production of some of the metabolite. Also, ethylene acts as a hormone that help in the ripening process. When you absorb more amount of ethylene, so that will delay the ripening. The next important type of smart packaging, we have carbon dioxide scavengers. So most of the time the carbon dioxide released due to the respiration, so that will be scavenged by some of the active ingredients which is present in active packaging. The next type of smart packaging is antimicrobial active packaging, which is mainly based on carbon dioxide, ethanol, and addition of some of the preservatives and applications of inorganic nanoparticles, and also addition of natural extracts. See how this antimicrobial active packaging works. Ethanol, generally considered as an agent that can kill the growth of microorganisms. There are different types of ethanol emitters that can be used in order to release certain concentration of ethanol, thereby it helps in the management of microorganisms. Also application of some of the preservatives. We have various types of preservatives. For example, the preservatives which are in the form of an acids. For example, ascorbic acid or potassium metabisulfate or addition of some kind of citric acid can act as an antimicrobial agent. Next comes with the inorganic nanoparticle, for example zinc or the gold or the silver nanoparticle generally act as an antimicrobial agent that can contain the growth of microorganisms. And we have natural extracts, addition of natural extracts, and these natural extracts are basically added into the packaging in order to contain the microbial growth. For example, addition of some of the essential oils or addition of some of the natural antimicrobial agents. So these types of extracts can limit the growth of microorganisms in food, and that can be applied into the packaging. The next important active packaging is antioxidant and oxygen scavengers. Antioxidants generally works in order to scavenge the oxidants. For example, the superoxides, or we have got the hydroxyl radicals. All these antioxidants and all these oxidants can damage the system, and also these oxidants can entirely spoil the food. So when we add an antioxidant, this is in the form of an ascorbic acid, or it's in the form of butylated hydroxytoluene, butylated hydroxyanisole. See, all these antioxidants generally they absorbs oxidants, or they scavenges the oxidants and makes it into a complete molecule. Sometimes oxygen plays a major role in spoilage. Let it be in the case of the browning or in the rancidity. So when we scavenge the complete oxygen, so thereby we can increase the shelf life of the product. The next smart packaging where active ingredients are used is thermal insulation packaging, based on phase change material. It's where the thermal insulation, the temperature, the control of a temperature, that is most important in the thermal insulation packaging. What are the properties of the active packaging, smart packaging technique is they interact mainly with food, releases or absorbs substances from food or environment, and ultimately they extend shelf life. The next type of smart packaging is intelligent packaging. Like I said in the beginning, intelligent packaging contain sensors that monitor and communicate the product's condition in real time. And these indicators, example, temperature sensitive label or time temperature indicators, freshness indicators and gas indicators, has been exposed to the safe environment, helping to ensure the product is safe for consumption. And some of the sensors, for example, the chemical sensors, which are electrochemical based, optical based, biosensors like electrochemical based, optical based, and edible sensors. These sensors monitor chemical signals, the atmosphere inside the package. This is typically useful in industries like food, pharmaceuticals, and even vaccines, where precise conditions are crucial. Like I said, the RFID tags, radio frequency identification packaging, is revolutionizing how we track RFID products. RFID tags use electromagnetic fields basically to track and identify products as they move through the supply chain. This technology allows companies to monitor inventory levels in real time. The barcode, the QR code, labels enable direct interaction between consumers and packaging. And this barcodes or QR codes enable a simple implementation. When scanned, can take a customer to a website for product details, promotions, or even recipes. And this is something which I have discussed earlier. So in the active packaging, this mainly refers to packaging that performs specific functions in addition to just holding and protecting the product. These functions also help to improve the quality, safety, or freshness of the product inside. And active packaging can control environmental conditions, can contain additives or substances that actively work to preserve the product by controlling factors like moisture, oxygen, and temperature. For example, in food packaging, Oxygen absorbers can be used to remove oxygen from the package, thus extending the shelf life of products like meat or baked goods. The release beneficial substances. Active packaging, they release the beneficial substances. And like I said, packaging might release antioxidants and antimicrobial agents to help preserve food or medicinal product. These are some of the examples I have already explained. Oxygen scavengers, these are commonly used in food packaging, particularly for products that are sensitive to oxygen like dried foods, snacks and coffee. The scavengers absorb the oxygen inside the package, which reduces oxidation and helps prevent spoilage. Moisture regulators, often used in food and pharmaceuticals. These packaging materials absorb excess moisture to maintain product stability. I said ethylene absorbers are also used in the packaging of fruits and vegetables to reduce ethylene gas, a natural ripening agent, and slow down the aging process of produce. The next we will talk about the intelligent packaging. So before I move on to intelligent packaging, I just want to tell a few things about smart packaging. Smart packaging is transforming the way we package, ship and consume products, whether it's through active packaging that extends the shelf life or intelligent packaging that monitors the conditions, RFID and NFC that enhance product traceability, or eco-friendly options that focus on sustainability. The future of packaging is clearly becoming more intelligent and interactive. Smart packaging offers a multitude of benefits of business, from improving product quality and safety to enhancing the customer experience and reducing environmental impact. Now we'll move on to intelligent packaging. Intelligent packaging, as the demand for fresh, safe and sustainable food continues to grow, innovative packaging solutions are emerging to meet these needs. Intelligent food packaging is more than just a protective layer. It interacts with its environment, providing real-time information about the food's condition. Let's explore how this technology works and how it's transforming the food industry. So what exactly is intelligent packaging? In essence, it's packaging designed to do more than just hold food. It's built with sensors, materials and technologies that interact with the food and its environment. These innovations help monitor and maintain the freshness, safety, and quality of the food. This goes beyond traditional packaging. It's a smart solution to the modern challenges of food storage, transportation, and consumption. What are the key features of intelligent packaging? Let's take a closer look at some of the key features of intelligent packaging. The sensors for monitoring freshness. The sensors are integrated into packaging to monitor variables like temperature, humidity, and gas levels inside the packaging. They can alert us if something goes wrong, like if food is exposed to the wrong temperature, reducing the risk of spoilage. Time temperature indicators. These labels change color over time to visually indicate whether a product has been exposed to unsafe temperatures, helping both consumers and retailers ensure food safety. Therefore, certain perishable products like dairy or vaccine require strict temperature control, and time temperature indicators can act as a visual cue for safety. Like I said, the gas detection. The gas detection in packaging of products like food, gases such as oxygen, carbon dioxide, or nitrogen may be monitored. And these gases help to preserve freshness or prevent spoilage. Intelligent packaging can use sensors to detect gas levels and indicate whether the product is still safe for consumption. For example, smart food labels. And these labels change color or display a message when the product has been exposed to incorrect conditions. For example, labels that indicate whether a product has been exposed to too much heat or cold. The smart medicine packaging that indicates the shelf life or potency of drugs through chemical sensors or indicators. And this is an example of different types of intelligent packaging where you can closely see the time temperature indicators. Also, we have a freshness indicator in case of intelligent packaging. We have RFID tags, we have barcodes, and also gas sensors. And these are some of the examples for active packaging where you can see the oxygen absorbers, which is in the sachet, moisture absorbers in the sachet, ethylene remover, odor eliminator, and oxygen scab generators. All these are in the sachet form. Similarly, the RFID packaging, also a type of Intelligent food packaging mainly uses electromagnetic fields to automatically identify and track tags attached to objects. This can be embedded into packaging to remove logistics, inventory management, and consumer engagement. The key features include product tracking. The RFID tags can store information about the product's manufacturing date, batch number, and destination. The RFID technology can help track products through the entire supply chain, from the manufacturer to the retailer to the end consumer, providing real-time data and reducing the risk of counterfeit or theft. Like I said, the RFID also used in inventory management, where retailers can use RFID to monitor stock levels, ensuring that products are always available and reducing the chance of overstocking or stockouts. Consumer engagement. Some products with RFID can offer interactive experiences when scanned by a smartphone or at the point of sale. For instance, RFID enabled packaging could trigger a digital coupon or offer when scanned. The clothing items, cosmetics, and other products also can have RFID, and these RFID tags can also help in tracing product shipments, detecting thefts, and optimizing logistics. Like I said, the QR codes and NFC, the near field communication QR code is a scannable image that, when scanned with a smartphone, directs the user to a website or app for more information. In the context of packaging, QR codes can be used to provide product details such as ingredients, nutritional information, or usage instructions. Direct consumers to online resources like videos, promotional campaigns, or customer reviews, which authenticate products to help prevent counterfeiting. NFC is a short-range wireless communication technology that allows devices to exchange data when brought closer together. With NFC enabled packaging, consumer can simply tap their phones to a package to access product information, promotion, or even loyalty points. The examples of NFC interactive food packaging, where scanning a QR code on a food package could provide recipes, cooking tips, information about where the product was sourced. Some of the luxury goods NFC or QR codes could be used to verify the authenticity of a high-end product. Ensuring the consumer receives a genuine item. And near-field communication. The brands can use the QR codes on their packaging to offer discounts, provide information about recycling, or offer feedback opportunities. We have next eco-friendly smart packaging. So So in the eco-friendly smart packaging, as sustainable becomes a growing priority, eco-friendly smart packaging focuses on reducing environmental impact while still incorporating smart features. For example, biodegradable food packaging with embedded sensors can maintain product freshness and also break down more quickly than traditional plastics. Some packaging even includes smart recycling features. Like NFC chips, this direct the consumer to local recycling centers or provide instructions on how to dispose of the packaging responsibly. And these are the another view of smart packaging. It's subdivided into intelligent packaging and active packaging. The intelligent packaging where sensors are indicators and data carriers, where we have gas sensors or biosensors. We talk about the indicators. In case of intelligent packaging, we have microbial, freshness, time temperature indicators, and data carriers, example barcode, QR code, RFID tags. So smart packaging, so we have active packaging where scavenging agents, releasing agents, the scavenging agents, so moisture, odor, gas absorbers, releasing agent, example antioxidants and antimicrobial agents. Intelligent food packaging. As the intelligent food packaging refers to packaging systems designed to interact with or respond to environmental factors. And these innovations help monitor and maintain the freshness, safety, and quality of the food inside. This goes beyond traditional packaging. It's a smart solution to the modern challenges of food storage, transportation, and consumption. And this is what is a smart intelligent identification of food packaging, the visual monitoring of food quality, production, transportation, sell and purchase. Sensors for monitoring freshness. These sensors track environmental factors like temperature, humidity and gas levels inside the packaging. They can alert us if something goes wrong. Like if food is exposed to wrong temperature, reducing the risk of spoilage. Time temperature indicators, like I said, they change color over time to visually indicate whether a product has been exposed to unsafe temperatures, helping both consumers and retailers ensure food safety. The smart labels and QR codes. By scanning a code on the packaging, consumer can access information such as the food's origin, storage conditions, and even its nutritional details. It adds an extra layer of transparency and traceability. And this is an example of intelligent food packaging which may maintain food quality over extended period. These are some of the parameters which are indicated: the rotting indication, the pH monitoring indication, and radio frequency indications. And increase the food shelf life, moisture and light control by using an antimicrobial, antioxidant, and oxygen scavengers or carbon dioxide emitters property. Again, go back to active packaging. So where release antimicrobial agent, some intelligent packaging. For example, some intelligent packaging contain substances like oxygen absorbers or antimicrobial agents. These agents either absorb excess oxygen or release preservatives to slow down microbial growth, helping to keep food fresher for longer. This is especially important for perishable goods like meat and fresh produce. Self-healing packaging. Imagine packaging that can self-heal. Some smart packaging material can repair themselves if they are punctured or torn. This helps to maintain the food's safety and freshness even if the packaging is damaged. In fact, this is a groundbreaking technology that can make food packaging more durable and resilient. Then we have an interactive intelligent packaging. Some packaging systems can change based on external factors like temperature. For example, certain materials may expand or contract to maintain the optimal conditions for the food inside. This creates a dynamic system that adapts to preserve food as best as possible. In addition to functionality, the sustainability is also a key focus. Many intelligent food packaging solutions are designed with biodegradable or recyclable materials. This helps minimize the environmental impact of packaging waste while still delivering the benefits of traditional packaging. In fact, sustainable packaging solutions are becoming a crucial part of the global shift towards eco-friendly practices. What are the applications of intelligent food packaging? How does intelligent food packaging benefit us in real world scenarios? Extended shelf life. By keeping food at the right conditions, intelligent packaging helps extend the shelf life of products, reducing waste and ensuring fresher food. Next goes with consumer convenience. With sensors and labels, consumers can easily check whether the food they are buying has been stored properly, ensuring better safety and quality. Supply chain management. Businesses benefit from real-time monitoring and tracking, ensuring that food reaches stores and consumers in optimal condition, reducing spoilage during transportation. Health and safety. By offering constant monitoring and alerts, intelligent packaging helps prevent contamination or spoilage, improving food safety overall. In conclusion, intelligent food packaging is a revolutionary step forward in making food safer, fresher, and more sustainable. From sensors that track food conditions to smart labels and self-healing materials. The possibilities are endless. As we continue to innovate, we will likely see more sophisticated and environmentally friendly packaging solutions that benefit both consumers and the planet. Thank you for your attention today, and happy to answer any questions you may have. Lastly, intelligent food packaging requires a balanced functionality, safety, sustainability, and consumer acceptability to be effective. It must prove food quality, be made from safe and environmentally friendly materials, and integrate smoothly into the food supply chain, while also providing real-time data to ensure food safety and transparency for consumers. Thank you for your patient listening.